All right, I wanted to go through another problem with you having to do with equivalent force and moments. It's certainly something that confuses some students, and so I thought I would add an extra problem to the course and just go through it. A relatively simple problem, but I think has a couple of good points on it. So if we take a look at the problem, I hope that you can see it here. It says the three forces act on the pipe assembly. If F1 equals 50 newtons, and you can see F1 at the end of the pipe going upwards, and F2 is, hold on a second, I've got the wrong thing here. And that's F1, and there's F2 right there. F2 is going down at 80 newtons. Replace the force system by an equivalent resultant force and couple moment acting at O. Okay, so one of the things that I think gets confusing for students is they'll see couple moment and they'll see and think, well, what does that really mean? And it really just means a moment, an applied moment. Okay, yeah, don't get too hung up on the word couple. It basically just means an applied moment. The idea of having it be a couple moment, oops, I can't spell. That should be an N. Um, the, uh, the reason for calling it a couple is they want you to think of the force and the moment as two different things. And a couple moment basically is a pure rotation without any forces. So we've got the force, give me the force, and then give me the pure rotation. But you could just say it's an applied moment, okay? There's nothing really special about saying couple moment there, okay? So what do we do? Well, the easiest thing here, and this is a relatively easy problem, is we first sum the forces, okay? We sum all the forces, and when we sum the forces, notice this is a 3D problem. We want to think in terms of the x direction, y direction, and z direction. Well, if you take a look at this, the only forces are in the z direction, right? So really, all you're doing is this, which is pretty simple. And we've got 180 down because I'm saying z is positive upwards. Okay, sometimes I'll write it like that. And make sure you can see that. 180 down. F2 is also down. That's so minus 80. But F1 is up at 50 newtons. And so then we would sum those together and we would get a resultant force as 210 newtons down in the z direction. So you could certainly go ahead and draw your axes here. Here's y, here's x, and here is z, right? And we can go ahead and apply that force at O, okay? So, because we're basically moving all the forces and moments to O. So there is a 210 Newton force that is straight down in the z direction at O, okay? We're applying everything at O. That basically the origin, right? Easy, okay? So that's the first thing. Is to do that. That's usually pretty simple. When we do equivalent force moments, the easy part is sum of the forces. Just sum the forces together, add them up, and move them to the point. Very simple. The only other thing you've got to do though is you can't just move forces. You have to account for the moments. So the equivalence is not just a force, but a force and a moment. All right, so we have to do moments here. We have to figure out what moments do these three forces cause. Okay, the 180, the F2, F1, what moments do they cause? Now, this is a 3D problem, okay? So I highly recommend, you don't have to do this. In fact, this problem, you could probably do it in your head if you're really good, but I wouldn't do that if I were you. Well, I would recommend anytime we see anything in 3D, we use the formula moment equals R cross F, right? And we realize that R, right, we have to define R very carefully, make sure we don't screw this up, right? R goes from, in this case, O, because that's the point that we want to sum moments about, to any point on the line of action of the force. So in this case, it's very simple because you're going to go from O straight to the force, and the line of action of the force goes right through the pipe. And so the pipe has those dimensions. It's going to be pretty simple, all right? So let's take a look at, we have three different forces here. So first we'll look at the 180 Newton force, right? We'll look at that one first. And that one's going to be 180 newtons times 1.25 meters, but that's not how I'll write it. What I'll write is R cross F, all right? And so what am I writing? Well, what's R? I go from O to the 180 Newton force. That's 1.25 in the I direction, crossed with F, and F is going down, so that's going to be minus 180 K. Now, in order to actually complete this, you would have to do the cross product. You have to figure out what is I cross K. Now, there's different ways to do that. Maybe if you want to use your calculator, you could, but I wouldn't recommend it. It takes a long time sometimes. But what I do is I use the right-hand rule. I take my right hand on the x-axis and I rotate it into the z-axis and look where my thumb points. Some people use the IJK thing in a circle, but you've got to know this for the test. You've got to know how to do a cross product, okay? You just got to know, whether you memorize it or something, you got to know this, all right? So it turns out I cross K is negative J, right? But there's also a negative in here, right? So what we really have is 1.25 times minus 180 times negative J, right? Well, because there's a negative there and the negative there, they're going to basically two negatives make a positive, right? And so you're going to get 225J. Okay, cool. We got that one. Now we got to do the other two forces. We got to do F2, right? F2, again, because we're 3D, we'll just go ahead and do R cross F. The R, if I go from O to F2, what am I doing? Well, I'm going 1.25 I, but this time I'm also going plus 0.5 J, right? I'm going both of them. I'm going 1.25 in the I direction. I'll map this out for you just to make sure everybody sees this. I'm going 1.25 in the I, and then I'm going 0.5 in the J, right? So that's how I'm doing it. Okay, I'm going to erase that line because it gets confusing, but hopefully you see that. Oops, I'm erasing everything. That's not good. Maybe I don't want to erase that line. All right, maybe not. Okay, we'll keep it. So anyway, not a big deal. All right, so we got 1.25 in the I, and we got 0.5 in the J, and then that's going to be crossed with, F2 is down, so it's negative, and it's going to be minus 80 in the K, all right? So now you got two cross products. You got the I cross K, which we already did, and we got the J cross K. So if you write this out, it kind of looks like this. You got 1.25 times minus 80 times, we know I cross K was still minus J, right? But don't forget, you have another term. You've got 0.5, you got the 0.5 times minus 80, and then you got J cross K. And it turns out if you do the J cross K right-hand rule or whatever, you get an I here, okay? You get an I. So what you're going to get here, if you add these numbers up, again, you got a negative times a negative, so that makes it positive. You're going to get here 100J. And then here you're going to get, well, half times 1 minus 80 is going to be minus 40, and that's going to be I. So minus 40I, okay? All right, so we've only got one more. It's not too bad, and that's F1. F1, again, we're going to do R cross F. Now we're going to go from O all the way to the F1. So we're basically going to follow the entire pipe. If you do that, you end up going 2I, and you end up going, well, still 0.5J, right? And that's going to be crossed with F1, which is going upwards at 50 newtons. So this is going to be 50K, right? And again, I like to put my little hats on there just to make sure, the little arrows, make sure you know we're talking about vectors here, right? And so now we do this math. Certainly we've got the 2 times the 50 times I cross k. Well, we've done I cross k a bunch of times now. We know I cross k is negative j. And then we got the 0.5 times the 50. And now we do j. This is a j, not a very good j, but we get a j. J cross k, and we know j cross k is going to be positive I. Okay, like that. And so we work this one out, and we actually get minus 100 j here, and we get looks like half, so that's going to be plus 25 I. All right. Now, what we do, I'm going to mark all of them, is we just have to add them all up. We got that one. We got that. And we got that. All right. We add them all up. Pretty simple, right? Add them all up. Sum all the moments, right? So if we sum all those moments, okay, what do we get? Well, you have to add the i's to the i's, the j's to the j's, and the k's to the k's. So you'll notice in the I, you get minus 15I. Notice how the j's cancel. You got 100j and minus 100j, so those go away. And then you got plus 225j. So we take that force, and then we also add in a moment, and that moment would probably look something like this. Okay, sometimes we write a little circle around it. Sometimes we do double arrowheads. I've seen that. But this is the moment O, and it's that vector right there. Okay, so we replace the forces there given with one force at 210 down at O and one moment about O, which is minus 15I plus 225J. And notice that even though this is a relatively simple problem in 3D, I still did R cross F. Almost everything in 3D, I think you're going to be better just doing R cross F. All right, hope this helps.